Okay. All right. So what we've got is, this is pretty cool. We're talking about sine and cosine now, and they talk about tangent, but we're not ready to prove that one yet. But sine and cosine derivatives are related to one another. And then somebody's being murdered. But let me go ahead and show you, say what they are. All right. So it kind of says it already in the notes here. But the derivative of sine is cosine. Now, we're going to prove that in just a minute. So we're going to prove it, but we can also kind of think of it graphically. We'll do that in a second. Now, the derivative of cosine is negative sine. Again, I can talk about that graphically and then through a proof. Now, this one's weird. The derivative of tangent is, I don't even know why they put it on here, just I guess so you'll know it's something different. It's secant squared. So you would take the secant of the angle and then square it. So that's secant squared. Also can be written as parentheses secant x, whole thing squared. Okay, now you're like, what? Okay, we'll prove that later. And there's a kind of a pattern to it, and you'll see, and hopefully it'll be good. Now, so here's the sine graph. All right, so a couple of things that you'll see right away. Well, that's a slope of 0. All right, so that's a slope of 0. So over on its derivative graph at pi over 2, I should have a 0. And looky there. All right, and then I got another one at 3 pi over 2. So that slope is 0. Okay, and so at 3 pi over 2, I should have that. Now, the other parts are a little bit, you got to kind of have to believe a little bit. But this slope right here, it turns out, now the scale is off a little bit because of, that's 1 and that's not 1. And so it's hard to really see. But that slope, if we were to graph it to scale, is 1. Maybe I'll show you that just real quick so you can see and you can believe. All right, so bye-bye to this one from earlier, sine x. And the scale here is pretty good. So like if I draw y equals x with a slope of 1, see, that kind of makes sense, right? All right, and then so that's what we're looking at there. And again, we're going to prove this a little bit better. But with that being 1, well, then at the very beginning of the graph, I should have, let's go back to, oh no, back, escape. Pen, blue, please. Okay, so on the derivative graph, I should have 1. Okay, oh, that happens over here too because, these things are cyclic and they repeat. So that's another 1. And then guess what's happening right here at pi? Well, it's negative 1. And there you go. And so if you were to connect those 5 key points there, you have the cosine graph. All right, so if this is, if this is f of x, is sine x, then its derivative is cosine x. Now, look, that's not a proof. We have a proof actually coming up here in just a second, but they try to show it in another way. All right, and it's kind of cool because your graphing calculator will graph these derivatives for you. So let's move that out of the way. And so just to serve as another kind of proof here, let's go clear that out. And I've asked it to graph, not yet, I'm about to. So I'm going to go math 8, graph the derivative of sine x for me for every value of x. So when x is equal to x. All right. And then if I graph it, look what it looks like. Doesn't look like anything because I'm in the right mode. All right, graph. The derivative of sine x when x is x. Yeah. And it's not doing it. So if I graph, let's maybe I'll zoom. Oh, there we are. Okay, I had a bad zoom. Okay. All right, and if you look, that looks like the cosine graph. Maybe I'll even zoom trig so you can see it a little bit better. All right. There we go. So I ask it to do it. Now, that's still not a proof, but it's heading us in the right direction. And just so you'll know, And we can do the same analysis for cosine. I really would like to do that. Working backwards. Yeah, I want to. And I know you probably already have written on your paper, but let me just kind of. It's not really a proof, but it'll serve as one. So escape here, erase, and let's do the same thing that we did in reverse here, though. All right, but I don't. It won't be this graph. Okay, so we would need another graph. All right, but anyway, but I want to do it though because just talking about this the same way I talked about this one over here to kind of prove that it's the derivative of cosine is negative sine. So here's the cosine graph. All right, and then let's start talking about the slopes again. All right, I've got a zero. I've got a zero here. I've got a zero here, and a zero here. So if I were to graph the derivative, so let me come over here and just let's get rid of all this. Now the secant squared one, we have to have another rule before we can do that. We have to have the quotient rule, but we'll get there. Okay, so zeros. Okay, very nice. So on my derivative graph, then let's go back to pen. On my derivative graph, I'll have a zero, and it's like you're like, whoa. And at pi, I'll have a zero, and that's looking like it's going to be the same thing, right? Except look right here. This slope is -1, not +1. So, it's not up here, it's down here. And then this slope right here is +1, not -1 like it was before. So everything got flipped a little bit. So at 3 pi over 2, I should have a +1. And then here we go. This is not the graph of sine. This is the graph of the opposite of sine. Okay, so the derivative, so that explains why, sort of, that the derivative of cosine is negative sine and not sine. That would be nice if they were the same. They're not. We've got a lot of coincidental things that are pretty cool, but that's not one of them. All right, so okay, next is going to be the actual proof of this. And you won't be responsible for that other than just having it in your notes.